Hello, I'm Cahit Parknözel from Çukurova University Computer Engineering Department, 4th grade. Today I will talk about MLP, Multiple Linear Perceptron. After the invention of Perceptron and Adeline, scientists realized that Adeline and Perceptron does not work well on problem data that has a complex relationship, and these type of models did not succeed well. So they invented multilinear perceptron. Let me show you the difference. This is multilinear perceptron, and this is a perceptron, which is this. So I will show you two examples. One of them is classification with MLP, another one is regression with MLP. So for both of them, I used train test split for twofold, and I use sklearn for the models and data. And for data, sklearn datasets make classification creates a random data for classification, and make regression creates random data for regression. But do not forget that these random data can have a bias, and yes. So for classification, I use MLP classifier, and they are pretty similar actually, but there are some differences. For example, stratify. Stratify means the classification value, that is the result classified by this value, and the samples. So this has more samples because if I had to learn a relationship that is a classification, for example, 0 or 1, this would be easier for me. On the other hand, if I had to learn continuous values between 0 and 1, there are more possibilities of relations, so it is harder. And when I tried it with n samples, it did not give a good score, so I get better score with 200. And also the iteration counts are different, because when I run this one with 300 iterations, I had a warning that's saying the algorithm did not reach, the weights did not reach the global minimum. So that means if you run it more times, your model will learn better and get better score. Also, MLP introduces a term which is called backpropagation. Backpropagation means the structure runs for one time, and afterwards, by looking at the results, backpropagation finds the error value, and using that error value adjusts the weights by that, so it learns better. And as you can see, the result is much higher, 88%, and this is 52%. It's also because this is classification, it's discrete, and this is continuous, so it couldn't learn that good. That's all. Thank you for listening.